Okay, we're looking at solving systems of equations. In the past, we've looked at lines. Where do the lines intersect? Now we're going to go ahead and look at some different types of functions. So in this case, we have a linear function, and we know this because this is x to the first power. This here, we have a quadratic function. We know this because we have x raised to the second power. And so what we want to do is we want to graph each one. So let's start off by graphing the linear function, y-intercept of 2, okay? And then slope is 1 over 1. So we rise and we run. I'm going the other way. Okay, so all the points on this line represent the solutions, or that's all the points on this line right here. So let's take a look at the quadratic function now. Now, without using a calculator, we're going to graph this. First of all, we know that the parent, the vertex of the parent, starts at 0, 0. And since we're in vertex form, it tells us the new vertex. The new vertex is going to be 4 units to the left and 2 units down. So 4 to the left and 2 down. So there's our vertex. And we also know that we have a vertical stretch of 2, and that this parabola is opening up because it's positive. So we go over 1 and up 2. And since it's symmetrical, we go over 1 the other direction and up 2. Okay, and then very simply the solution to this system, remember a system is more than one equation, is where they intersect. So in this case, they're going to intersect at -4, -2. Okay, so in this case, there's only one intersection point. Now let's take a look at another example using Desmos. Looking at this example, we have a linear function here and a quadratic here, and notice that they intersect in 2 points. Now, we would just approximate here. Looks like it's going to be about 2.2, 3.2. That would be one solution, approximately. And then the other one, approximately 6.8 and 7.8. So 2 solutions. It's the points that they have in common. Now, since these are both equations, they're specific points. But let's say we make them into inequalities. Now notice that the solutions lie, all these points below this line are solutions to this inequality. Okay, if we change this one, notice all the solutions below the parabola are solutions. And so the solution to this system would be where they overlap. So any point in this double shaded region would be a solution to this system right here. If I change that to a greater than, then the solution would be located inside where they overlap. But since these are dashed lines, none of these points are solutions. The border is not a solution in this case. If it was a solid line, then yes. Okay, so always remember where they overlap. Okay, well that's a 5-minute video. I'll see you guys on Monday.